Hi, welcome to lesson 22b, sample space. The goal of today's lesson is to learn about sample space and how it impacts probability. So in 22a we're talking about experimental probability, and we're talking about trials and the outcomes and the frequency, etc. of the event occurring. And the sample space is basically the set of all possible outcomes of an experiment. It can also be referred to as the universal set. So one way to imagine the universal set is to imagine a box or a rectangle. And the events that we're talking about, the sample space, may belong to one set of things in this box or another set or neither. So, for example, if we're talking about, and we've used Venn diagrams before, I'm sure. So if we have, for example, this box, here's the universal set. Suppose, for example, we're talking about flipping a coin. And we're talking about odds and evens, something like that. So if we talk about, odds and evens, they don't have any, there's no overlap there. But if we do odds or evens, then we know that rolling a die, we've got 1, 3, and 5 as the odd numbers, and of course 2, 4, and 6 for the even numbers. We could change that up a little bit and say, okay, well, let's talk about composite numbers. So if we draw another, now I know I should be using a ruler for this, so I apologize for the rough nature of these universal sets I'm drawing. So let's take a look at the possibility of, again, rolling a die and having an even number appear, or having a composite number appear. Okay? And rolling a die is part of the universal set, so all of the numbers 1 through 6 will appear in this universal set. So first of all, we roll a 1. Well, a 1 is not composite and is not even, so 1 is going to be outside here, but it's still inside the universal set. 2 is even, but 2 is not composite. It's a prime number. Then we go to 3. Well, 3 is not even or composite, so it goes down here. 4 is even, and it is composite, so we put the 4 here. 5 is not even or composite, so put the 5 there. And then we look at 6, and 6 is even and composite, so we put that there. So we see that by using this diagram, this box, it's a Venn diagram, but this box and certain outcomes inside in the universal set, all of the outcomes of rolling a die they appear in either one of these rings, or both, or none. But they are all inside the universal set. There are other ways of representing sample spaces. We can look at lists. We can look at table of outcomes. We can look at two-dimensional grids. We can look at Venn diagrams, which we have right here. And we can also look at tree diagrams. So if we talk about lists could be kind of exhaustive and cumbersome. We can look at the lists of tossing a coin, for example. And when you toss a coin, we've got heads or tails. Okay, well, that's not a very long list. Suppose we're looking at the list of rolling or tossing a coin 50 times. Okay, well, then we'd have to list, well, actually, it's still heads or tails. Those are the possible outcomes. If we look at rolling a die, we've got 1, 2, 3, 4, 5, and 6, of course. There can be other things that give us more outcomes. Like, for example, if we're talking about rolling 2 dice, for example, we'd have 1, 1, 1, 2, 1, 3, 1, 4, etc. Then 2, 1, 2, 2, 2, 3, etc. 3, 1, 3, 2, yada yada yada, all the way. So that ends up getting very exhaustive. Now, if we took it even further and rolled 3 dice, or even flipped 5 coins, and listed all those, that would get pretty cumbersome. Okay, so lists can be pretty monotonous. Then we look at two-dimensional grids, and a two-dimensional grid is where we're comparing only 2 trials or 2 comparisons being made. Okay, so suppose we're flipping a coin and we're rolling a die. Okay, so if we do that, we've got 1, 2, 3, 4, 5, and 6 for rolling the die. I should be using a ruler, I apologize profusely. And flipping a coin, we've got heads and tails. So then what we can do is we draw the grid, hence the two-dimensional grid form. And if we're looking at rolling a 3 and flipping a head, we would just see where the 2 connect, and there's our outcome. So each of these intersections is a different outcome, and this would be 1 out of those possible 12 outcomes. Okay, or we could say, what about an even number and a tail? Well, even number and a tail, we look at the 2, the 4, and the 6, and where it combines with the t, so that would be 3 out of the 12 outcomes. Okay, so that would be a two-dimensional grid. So that's only good when we're comparing 2 items, or making 2 comparisons. When we get into tree diagrams give us a little bit more effectiveness than the two-dimensional grid, and basically we start at one thing and we're branching off many different ways. We could branch off twice or 3 times or 4 times or 8 times. It doesn't really matter. It depends on what we're comparing. And then from there we could branch off again. Okay, so hence the appearance of branches of a tree. Okay, but we will look at more of that tomorrow in class when we look at a few more examples. Okay, so that's basically that. When we talk about sample space, we're talking about all the different outcomes that are possible in a different experiment. So what I'd like you to do after we finish off this, please take a look at examples 1, 2, and 3 from pages 574 to 575, and please click on the self-tutor to allow her to explain the solutions to you. And then you can take a quick look at exercises 1 to 3 on page 575, and that will give you a little bit of an idea of what's going to happen or what we're going to be looking at in class tomorrow. But like I always say, you don't have to work on the exercises to practice your skills right now. We will have time in class to work on those after we go through the examples. So that is the end of 22B. Thanks for watching, and we'll see you in class.